Welcome everyone to the ESC Texas Education webinar of the month. Today, our focus and our presenter is going to be discussing how to capture energy savings and achieve resilience through ultra low loss voltage transformers. Tim Van Horn's with us, active member of ESC with Powersmiths. And before we turn it over to Tim, I'm going to let Cassidy Ellis make a few announcements.
Hello, everybody. Yes, we just have a couple quick announcements. You all know what the chapter is. We don't need to go through this. We have our next chapter meeting on March 3rd, 1 to 3 p.m. I will send out the invite to the chapter today to get that on your calendar. It's going to be virtual as usual, or as it has been. And a reminder that we will be doing chapter elections. The nomination forms will be released soon. And if you are interested in running for any of the positions, and I believe all of the positions will be open this time, none of us who are currently on the executive team are planning on running again, except Fred Yebra, who will hold the public sector co-chair position in perpetuity. If you're interested in being nominated, please reach out to me. I'm happy to nominate anyone who's interested, or you can nominate yourself. And then we will be having the rest of the election cycle as described there, including the opportunity to present your interest in running at our March 3rd meeting. And with that, we will actually turn it over to our speaker, Tim Van Horn. And Tim, you can share your slides and tell us a little bit about yourself and about the company.
But before we get started, just a reminder, Cassidy, we're recording this, right? So this will be available on the ESC or linked to the ESC chapter's webpage for viewing later if you've got colleagues that were unable to attend live this morning.
Yes, it will be on our YouTube channel, and then I will get it over to National to post it to our chapter website as well.
Perfect, thank you.
Well, I appreciate everybody. Tim Van Horn. Been with Powersmith for almost 17 years, going on 18 years. And I really started out with the premise with Powersmith was running or starting the ESCO division, I guess you could say, the Energy Service Division, and have grown it, throughout the United States now. And my focus right now is just Texas over to North Carolina. Long story short, but just that's all I can handle anymore. So we've got people all over the country now, project development engineers, M&V engineers, you name it. Our engineering team is out of Virginia. So we're here to help. Just a quick little brief intro into Powersmith, and we've been, why is it not advancing? Oh, there it is. Okay. Established in 1996. We were based in Toronto, Canada. We've got 5 product families, and I'm only going to be talking about one today. And this is the ultra efficient green transformers that you guys have seen all over the country, and over the state of Texas, actually. Very successful in the state of Texas, and I'll get into some of those in the near future. Medium voltage transformers. We just recently got into medium voltage transformers. Our new CEO came from ABB out of 25 years. And actually one of our partners are in Waco, Texas on the oil field transformers, Vantran. Data centers, we're all over data centers. We're probably, you go to Google, Facebook, Apple, you name it, you'll see our stuff in their data centers. In Texas, we're really big at MD Anderson down in Houston. Metering logic, metering logging products all across the board. A sustainability management system where you can bring all your platforms of all your ECMs into one platform for STEM, understanding the energy and consumption and patterns of your profiles of your building and so forth and so on. So get into the real thing. Powersmith, we've been in the retrofit market since 2003. We conduct all the audits, we do all the M&V and baseline measurements as at risk. So, we've probably done in the last 5 years, probably saved our ESCO clients about $85 million, or generated revenue of about $85 million for those ESCO clients. Why look at it? So you're looking at KWH savings and demand savings, verifiable savings, embedded for 30 plus years. You won't see an ECM that's got a better SIR than you will a transformer. There's no controls or behavior, change. I mean, long story short, I did San Antonio International Airport, and one of the M&B guys was the last one in there doing the project, and he was talking to me, and he goes, these transformers, I make sure that these are on every project. And I said, why? He says, because the customers see it, they don't feel the heat, and they don't hear the noise. And he says, I can put the best control system in the world in this airport, and we leave, and 2 years later, somebody changes set points on the chiller, and there goes our savings. So he says, you can't change the savings on these transformers. No efficiency or loss aggregation over installed life, refresh a key piece of electrical infrastructure, restore compatibility with electronic load profiles. I mean, the older transformers don't, they weren't compatible, 30 years ago with the electronic profiles of today. So that's why one of the reasons you see them so hot and buzzing in these electrical rooms. Impact beyond energy, CO2 lead. I mean, our transformers are pretty much the only transformer in the market that you can actually gain some lead points on the energy saving side of it, because to be a lead, to gain any points, you have to be above and beyond the standard. And we're about 50% less losses than the standard transformer of today. 32-year performance and guarantee warranty. You won't see that anywhere else either. And it's the most sustainable ECM you can install. You install it, you forget it, you walk away, you're done. And guaranteed savings for you and your clients. So that's why you're looking at them. And then this is another thing. This is the Department of Energy study. There's about 50 million dry type transformers in the United States, and every building, all vertical markets, and about 65 to 75% are 30 years older or older. And meantime between failures, 32 years, hence our 32-year warranty. The energy impact is, 70 to 90 billion dollars of annual losses, KWH losses, environmental impact, the financial impact at just 10 cents a KWH is, tremendous. And then what we're seeing across the board is about 80% reduction in losses. So, it's a good solid ECM. It's something that, should be put on every project. And I'm trying to get most people to look at it. The problem that we have a lot of times is, I'd say 98 to 99% of all the engineers in the energy world are mechanical engineers, and they focus on the mechanical equipment, the controls, the boilers, the chillers, those types of things, and HVAC equipment, and they look at lighting and so forth. We're trying to change that pattern, and we're doing a pretty good job at it in Texas. So here's another study. It was done by Oak Ridge National Labs. And over the last 45 years, oil field transformers, those ones that sit outside, the green ones owned by the utility, have gone up in efficiency and lower losses because it was driven by the utility. Because if you think about it, the utility, the output of that transformer. So any losses in that transformer is coming out of the utility's back pocket. So conversely, dry type transformers the last 45 years have gone down in efficiency and higher losses because it's first cost. It's the cheapest one I could buy. You go down to Gray Bar, I need a 75 kVA transformer, give me the cheapest one, I'll put it in. And that's essentially what you had up until about 8 years ago. So, they're everywhere. You never know where, never know what happens behind closed doors. These are the things you see. They're sitting in electrical rooms like this, using as a shelf, or at least they put contact paper on top of this one to, eliminate the spillage of the bleach on top of it. You'll see it everywhere. You'll see them outside, sitting there rusting. They're everywhere. So, it's a key piece of electrical infrastructure, embedded verifiable savings for decades, excellent return on our investment. So, just to let you know, we're talking about low voltage transformers. We're not talking about the transformers. That's a whole nother presentation. Not the transformers on the pole, not the transformers outside, the ones inside the buildings, in these electrical and mechanical rooms that you guys have probably walked into and seen hot buzzing transformers and wondering why they're like that, and because of the high losses in those transformers. So there was no efficiency perspective at all until about 2007. And then they came up with EPAC 2007, and they started at a standard that talked about, what's your efficiency at 35% loading? Well, and they were always talking about linear loads. And so, which is, you never see linear load out there, you see nonlinear loads. So now you've got a little stricter efficiency standard, but it's still based at 35% linear load. And there is no linear loads out there. It's all nonlinear. And at 35%, it's not real world loading profiles. So we look at the loading profile across the whole spectrum, 0 to 100%. So that's what we're looking at now on transformers. So the majority of the losses in a transformer are the core losses. Those are the losses that are 7x24, 365. So you turn on a transformer, and you go home at night, you turn off all the lights, you turn off all the computers, that transformer is still on. And there's core losses in that transformer 7x24, 365. And then there's coil losses varying with load. So, you look at this and you look at a standard 75 kVA transformer, just a standard 75 that you see everywhere in every building. It's a very common transformer. By code, if you have a 225 amp 42 pole panel, you've got to have a 75 kVA transformer. So that transformer is just sitting there doing nothing. You went home at night, it's got 750 to 850 watts of no load loss, just sitting there humming right along. And a good story is I did a school system here in Florida. And I walked in, the particular ESCO brought me in and introduced me to the facilities director for the school system. And I explained to him what I was doing. And he popped up out of his chair, turned around, ran to a file cabinet, pulled out a file, and he goes, I've been wanting somebody to tell me that I was not, insane. And he goes, well, I said, what do you mean? He says, well, during the summer, our meters were still spinning and we had everything off in the school. And our meter was still spinning outside. And I figured out it was the losses in the transformers that making the utility meter spin. So they're sitting there. So our transformer is about 111 watts of no load losses. It won't come out of the factory if it's anything higher than that. So if you look at that, it's approximately 700 watts. It's like having 7 100-watt light bulbs on forever, just sitting there on. This is just one transformer now, just on. So, what's that look like? Typical school system, $100,000 over 3 years in a typical small school system. And now add the savings when the transformer is loaded. So an example is El Paso ISD. We just completed that project. We just did a M&V report in December for that particular project, and we saw 84%, almost 85% reduction in losses in that particular project. So loading, typically, I don't know if anybody's can talk. What do you think the loading profiles on these transformers are? This is another study that was done by Catamus. We didn't do this study. This is what you see across the board. Typically they're running right around 15% loaded. That's what transformers we see all the time, is about 15% loaded. So it's on the low end of the efficiency curve. So that 35% really doesn't mean anything. So we looked at that and said, okay, let's take some measurements ourselves. So I took some measurements and I did a quick, just 46 transformers that we just randomly selected. And we had one that was above 35% loading. So you look at this aspect of it and you're saying, well, it's not a real factual loading profiles. And we see this across the board. I mean, I'm talking about every particular project you could possibly see. So this is pretty blown up and everything. It's very difficult to see. So what I did is I just took two of them and just did an example. So you've got two schools, both at 75 kVA. One's at 3.3% loading. The other one's at 3.2% loading. And you see the efficiency difference between the two of them. This is the same school, it's two different transformers at two different schools, but same loading profiles. So just that particular transformer is about $1,000 per year that they're saving if they just replace that transformer. So if you look at that, through a life of a project, life expectancy of that transformer, that is substantial enough to look at. So, it's just an example. If anybody has any questions, I'm trying to go fast because I know that everybody's busy, and I think it's we're already at 20 minutes in. So is there any questions at this point? I don't see anything on the chat. Cassidy, am I not looking at something right?
Yeah, no, you're nothing in the chat yet. Remind
Okay.
everyone on the line, if you would like to speak, you should be able to raise your hand and I can allow you to talk or put in comments or questions in the chat.
Thank you.
Tim, this is Dub. So cutting in here, but with a question, and you may be getting to this, but does Powersmith have a spreadsheet or some other type of calculator that can be used to plug in some of these numbers, base case situation versus improved, and better understand kind of the math behind some of these investments?
We've got white papers, we've got, you name it, we've got calculation sheets. I mean, typically when we do these projects, we're sending out, like we're doing Goose Creek right now and ISD, and I've been inundating McKinstry's with spreadsheets and follow-up data. So
Okay.
It's very, very typical. We don't, and I'll talk about how we go about everything in a little bit, but I mean, it's very typical. All this stuff is readily available. We're very transparent. Here's all of our calculations. Our spreadsheets are wide open. You can look at the formulas, everything. So yeah, that's not a problem whatsoever. It's just basic math. That's essentially what it is.
And Tim, I also have a question. And again, you may be getting to this, but do you typically work with ESCOs who are putting together projects for customers? Or are you working directly with clients? Does that vary?
I'd say my division, I'd say 100% of the time we're working with the ESCOs.
Gotcha.
We're working with the Amoriscos, McKinstry's, ABM, Johnson Controls, Siemens, Honeywell, of the world. So we work with them. We're just a subcontractor. We're just one of their ECMs. I'd say I'd go back 99% of the time. Sometimes customers find us out and say, hey, we just want to do a retrofit and of this particular commercial office building or something, and there's no other things. Maybe they've already done the lighting and the HVAC and they just want to come do the transformers. It just really depends. But I'd say 99% of the time. I won't say 100%, 99% of the time. Because there are some end users, the bigger end users, like I mentioned, MD Anderson down in Houston, Apple, Google, Dell in Houston, those types of Facebook, that come directly to us, for retrofits of transformers. And our other divisions that I mentioned, especially the data center divisions, those work directly with the customers. That's a whole nother vertical market that I'm not involved in, so not at this time. I was back in the day, but not anymore. So I'm just focused on the retrofit, the energy saving side of the business with low voltage transformers. So hopefully that answered your question. So, and this is another, I wanted to show you this. Is the state of Delaware. They had these DOS facilities, not DOE, it's the Department of Health, I think, facilities, DOH. And they had the same they had the same building all across the state of Delaware. And all they did was they duplicated the building so that every building had a 300 kVA transformer, and you could see the loading profiles of all these 300 kVAs. They're sitting there going, why are we putting in such a large transformer? And I told them, I said, well, by code, you have to, because the engineer designed the building to handle this much capacity, amperage, and by that code, you have to have the 300 kVA transformer. So, all the engineers, I'm an electrical engineer, and you don't oversize things, but you have to go by code and then put a little CYA in there. So that's what you have to do. So this is KW loss comparison. So this is the real world that we're seeing. So the typical loading profile that you're seeing on the left-hand side in blue is what we're seeing in the field. So you can see the differences of the no load losses. That's where the energy savings is, sitting right there at the no load losses. So you look at it, everybody goes, well, what's it at 30% load, 40%, 50% load? And I go, well, we're still better. There's no doubt about it. But that's not what you're looking at anymore. You're looking at these low loading transformers across the board. And people always say to me, they go, well, this thing's cooking in this electrical room. It must be really loaded. And I go, no, it's not loaded. I bet you it's no more than 20% loaded. And they go, no way. Why is it so hot? I said, because of the losses there. And I said, think about it. You got a 75 kVA transformer with 700 watts of, no load losses. With loading is probably 1,000 watts. It's like having a hair dryer on 7x24, 365, just sitting there cooking. So a hair dryer sitting there for a long time is going to be hot inside of a metal case. So it's going to be hot. So it is what it is. So it's and this is the DOE, this is versus linear versus electronic loads. So you can see that, the 35% loading is not really true. And this is what we're seeing across the board. So you see, there's no linear loads out there. You're not running heaters and resistors in your buildings. You're running computers and electronic ballasts and so forth and so on. So that's what you're running. You're not running resistive heating. So especially in Texas. So this is the 5% limit that you see a lot of times for THD. And as you can see, this the load current distortion. Everything's way above the 5% that IEEE goes by. So, we're seeing non-linear loads of transformers across the board. And then the next thing is heating. So you look at heating. So especially in Texas, I'd say a majority of the electrical rooms that you see in Texas are cooled. And the only reason they're cooled is because the heat being generated from the transformer. So now you've got this, you've got a transformer sitting in an electrical room being cooled by the chiller, and you're cooling the heat that shouldn't be there in the first place. So now you've got more energy consumption. So this is a great example. This is this is a transformer I measured just on the cover, 233 degrees. So, and in this particular school system, they had a dedicated DX system in every electrical room in every school. And so you look at that, you're going, okay, I mean, all they're doing is putting a Band-Aid on it. They're not fixing the problem. They're just putting a Band-Aid on the problem. So, funny story was in this particular school system, the facilities director called me a year after the ESCO got done with this project. And said, hey, you guys missed 3 transformers. I mean, it's common. I mean, because you're going through the school system, a very large school system, and you're relying on people showing you the right rooms and so forth and so on, and you're looking at drawings and things get changed. And he says, hey, you guys, out of all the schools, you only missed 3, but I want to buy those 3. And I said, how's the new ones coming along? And he goes, oh man, it's great. He says, it cost me about $9,000 per electrical room in every school. So in some schools, there's 10 electrical rooms, 15 electrical rooms, 3, 5, whatever. He says, but it costs about $9,000 per electrical room to put a dedicated DX system to cool the transformer. Now that we've replaced it, I could have just replaced the transformer, a $4,000 transformer, and not had the DX system in there. He says it makes total sense why we didn't look down this path, because a lot of people just assume that they're supposed to be hot, humming. It's just not supposed to be like that. So That's just a good example. This is another good example. This is right here in Texas. This is Randolph Air Force Base. So we just got done Joint Base San Antonio. So every one of the transformers on every one of the bases in Joint Base San Antonio has been replaced. And I walked in the electrical room and I saw this picture and I had to take it. And I said, that is unbelievable to see that this is the way they dissipated the heat. And actually it was going back into a cool plenum. So they were putting heat back into the cool the plenum to be recycled throughout this building. So this is a good example of the heat that I'm being generated. This is another example of we just took a before and after of electrical room, just a 75 kVA transformer. And this is the ambient temperatures of the electrical room before and after. So, you're looking at 30 degrees worth of reduction in temperature in that particular electrical room. So it's I know I'm going through fast a lot, but I mean, slow me down if you have any questions. This is proven real world losses. This is it right here. I mean, this is where we're seeing the scatter plot, or the blue we're measuring in the field. The NEMA TP1, the DOE 2016 is the red, and the green is what we provide. And it's something that's going to sit there and last you for 30 years plus. I always tell everybody, you replace a transformer today, I'll most likely be 6 feet under before you have to replace it again. So it's something to think about. So and I guess I'm going through that same slide again. I don't know why. So how does it actually save energy? I mean, it's just, everybody asks us this, and I just want to explain it as best I could. So we're looking at everything on a transformer. We're looking at the steel that we're using. We're looking at the windings of the transformers, the highest grade steel you could possibly buy, the core technology. We're looking at everything. They're built by actual people. These aren't built by machines. I mean, they're built by actual people that actually do it by hand. So what's the guts of a high performance transformer? I already talked about the core. You're done a higher grade steel, mitered and wound, 2 to 3 times less losses than the typical transformer. You're looking at a better design. This is the typical design of Square D's and GE's and Siemens and everybody else's Cutler hammers in the world. They've got a core shape like this, where if you're looking at it, the current being flown through the transformer is actually bumping up against resistance at every corner. So, it's going to create losses, resistance, which creates losses, which creates heat. And where we come about, we're putting almost a miter. We're using miter joints. So now the resistance is less, a little taller core, but resistance is less, and then you're going to have less losses in the core than the eddy current losses and the I²R losses. This is just an example of our stacking of our cores. And the coils, smaller air ducts, close coupling, cleaner voltage. Now you're getting a cleaner output voltage of the what's coming into that particular transformer. And again, the coil height, I already mentioned it, it's a better transformer design. We're always tweaking. We are always tweaking this. If we can figure out a better way to get less losses in a transformer, we're doing it. And we're changing things on a yearly basis, just tweaking it. Even if it's 2 or 3 watts, we're tweaking it. So, and then, you're looking at the framing side of it. The framing is, you go in these buildings and you hear the transformers. A great example is I did a project for Schneider. Schneider actually, builds their own transformers, Square D. So I did a project in North Carolina with them. And just before the holidays, I got an email from the project manager, project development engineering manager. And she said, hey, we want to replace the rest of those transformers in the school system. It's a big school system, about 40 schools. And they, for some reason, budget cuts and so forth, they had about 20, they cut about 20 of the 40 schools out of the project, of the transformers out of the project, because they needed HVAC before you need transformers in schools. And so I go, how did it go? She goes, she's wrote in this email. She says, the school system wants us to go back and look at all the transformers in the second phase because the teachers are complimenting the lack of noise and the lack of heat of these transformers. The teachers are complimenting them. And because, a lot of these electrical rooms are being used by, storage, which they shouldn't be, but they're used for storage for AV equipment or whatever. And the teachers are walking in there, and they always walked in there. Now they're walking in there. They said they feel safer because it's not noisy and loud and hot. So this is a better transformer design. So you look at this right here. So this is a typical design that you see everywhere. So if you squeeze the two outsides of a transformer of the core, what's going to happen if anything, you do anything like this? The inside is going to go out. So that's the reality. So, it creates noise and heat. And the improvement is what we're doing. So we put another brace on it that's convex like this. And then as we squeeze the core, it gets tighter and tighter in the middle and not go out. So it's little things like that we're doing. Advanced installation, low VOC. We're very, very conscious about what we're doing across the board. You walk into our factory, you walk into most transformer manufacturers' factory, it's a pretty dirty place. You can eat off our floors. I mean, so we're looking at the epoxy we're using, the low VOC, the framing, the pallet we uses 70% less wood than the typical pallet, and it all comes from a sustainable forest. Even the shrink wrap that we use to ship the transformers is biodegradable. So we're looking at everything because we're ISO 14001, and we're thinking that, and because of the pallet itself, now you can put more transformers on a truck to be shipped, thus less fuel cost, thus less impact on the environment. So we're looking at everything. So, and just to let you know, so how do we go about all this? So, we've come up with best practices across the board. And, typically what happens is our clients will get a hold of us and say, hey, we've got a new project. What do we have to do? And so they start sending us information. We go through the preliminary assessment, investment grade metering, and so forth. Let's just go through this. So preliminary assessment. So if you get a project out there, what happens a lot of times is the ESCO or the client itself will send us electrical one lines, and we do some preliminary back of the envelope calculations and say, hey, this is what we think you're going to save in energy, because we've got a historical database that measures 500,000 transformers that we've measured actually in the field. So we know that GE 9223B 7485 transformer is going to be this type of losses. We already know that. So we'll come out there and give that information. And then they say, okay, let's take the next step. And then we do an investment grade audit. So we're looking at the investment grade audit. We come out and put boots on the ground. You've got every transformer gets a specific red tag. And that red tag, that number on that red tag follows us through the IGA, through the M&V, through the engineering, through the manufacturing, and to the installation. So every transformer we build is custom made for that particular application. So we look at this, we're building similar footprints, similar impedances, and similar load configurations. So when you're looking at this aspect of it, so this ain't off the shelf transformer. So you've got that transformer, you could have 375 kVAs in one electrical room. That'd be 3 different sizes, 3 different load configurations, and 3 different impedances. So that installing contractor knows when it comes in, they'll look at that number, and that number is on a permanent label of the transformer also. And it comes with a green label with that same number on it. And he knows that transformer goes exactly in that same location that number is. So there's no confusion, and it reduces installation costs, thus reduces ROI, and everybody gets the transformer they need for that particular application. Retrofit considerations, we're looking at everything. This is one way to get heat out of it. We're looking at, how it's designed, how it's installed, so forth and so on. We're looking at the heating aspect of it. Is there AC in the equipment? Then we come back and do the baseline M&B. We're looking at a meter that was, it's unparalleled in its capacity. We spent probably $5 to $6 million developing this meter. So we're measuring, and we don't sell it. That's the crazy thing. We don't sell it either. So, you're looking at we're measuring the primary and secondary side of the transformer simultaneously. So we can look at the real-time losses coming across this. And, the accuracy is a 0.2% accuracy on the particular transformer. And then we also, all of our meters are calibrated to the CTs, because there's always hysteresis. There's a little bit of calibration in between every CT and the meter. So we're looking at this. We look at everything. I'm telling you, we're a bunch of engineers that just, I think we enjoy making sure that we're right and we're correct. So, and all of our field personnel are 70 NFPA 70E trained. We understand what the arc flash PPE categories are. We understand all this stuff. We can do this stuff in the field and be very, very safe about it. This gets to you, Dub, what you're talking about calculations. So all of our calculations are very transparent. This is just, if you look at this, it's very difficult to see. This is just the overall savings summary, but every building is now a line item. So every transformer is its own line item. So if you understand a lighting audit or so forth and so on, where you can turn on and turn off every one of the lights, in a particular audit, in line item every transformer, and that is the way it is in every one of these tabs. So you can go back into those things and say, you know what, they're going to retrofit that side of that campus next year, so let's turn off these buildings or these transformers. So you can do that, we can do that, and we do it as a collaboration between the end user, the ESCO, and ourselves, and we do that, and we provide the right calculations and the right project for what is happening in that project for the next 5 to 10 years. And we put together a proposal. I mean, it's pretty simple. We look at all the options. We can do all types of options. We can put meters on transformers. We can put doors on them. We can put IR ports. You put breakers on them. So whatever is necessary in that particular project, we can custom make it for that particular application. So there's nothing that we can't do. So, I mean, people ask us all the time, can you do this? And most likely the answer is yes. Most likely the answer is yes. If you need something like this, we can do it. Then the solution. So this is where I was talking about the lug type of configuration. So if you look at the top left, that's the way that particular transformer manufacturer built their lugs. So if you look at that, they're coming in, they're all ways. I mean, you've got X3, X3, H3, X2, H2, so forth and so on down the line. So we looked at that. We go, okay, that's not going to be feasible. Why don't we just put all the H's on one side and all the X's on the other side, so the customer and the installing contractor would have plenty of room to have his cables. And everybody does it differently. I'm telling you, everybody does it differently. It just depends on the manufacturer and what they do. So, I mean, so we customize those lugs. So now it's going to reduce the installation costs. Again, reiterate, reduce the ROI on a particular project. So field measurement, now we do the post M&V. So now we're doing the post M&V, and I'd say 98% of the people do the ISO 17225 certified test lab, or so we've already done the baseline M&V. We already know what the impedance, not impedance, we know what the harmonic content is, we know what the voltage, we know the current, we know the temperature. So what we do is after that particular transformer, we know it because it's got that tag number on it, that red tag. That particular transformer we measured in the field goes and gets sent over to a certified test lab, where they duplicate the same requirements as same baseline information as they had when we measured it in the baseline. So we're doing apples to apples comparison. So, and what we found out in the past when we were doing option 2 in field metering is you might be coming in there on Tuesday at 4 o'clock in the afternoon doing the baseline, and then come back at 9 o'clock on Thursday doing the post, and it could be 2 different loading profiles, so forth and so on. And just, it wasn't comparing apples to apples. So it was more apples to oranges. So this is the way most people do it. And it's safer too. So you don't have to reopen up another hot transformer. So then we develop an M&V report and provide that M&V report to the particular client. And you know, this is what we do. This is how we go about this whole project. We go from soup to nuts. We pretty much hand somebody a project, and then they take it and either, like I said, 99% of the time, they'll take it, mark it up, and send it on to their client themselves. So there is some cases we do some direct stuff, but very, very seldom do we do that in my division. So here's some sample studies, just quickly. Let's see how much time I have. Sample studies. You know, this is a GSA project that we did, and I use this as a study because this could be any commercial office building. This could be anything. This is just a GSA building and outside of Washington, D.C. that we did. So, you know, commercial office building, typical things you'd see in DFW, Austin, you know, Houston, you name it, San Antonio. So this is, you know, the amount of energy we're saving per year, you know, over 600,000 kWh per year. What's the CO2? I mean, that's a lot, 462 tons of CO2 just by replacing these transformers. You know, going down the NOx and SOx, how many plants did we, you know, save, so forth and so on. So this is really, you know, things that we do across the board. We can do these studies for any particular project. This is a good one. This is a school. This is I believe this is an elementary or middle school, and it's a middle school before and after. So if you look at the graphs, the scaling of both graphs are exactly the same. So we did do this one in the field. So you see the red at the top is the efficiency, the blue is the losses, and the green is the loading profiles. So, you know, and you look afterwards, you can see where the red is, the efficiency. You can see the blue where the losses are, and the green is the loading profiles. The loading profiles pretty same. So, you know, we're looking at, you know, almost 80% reduction in losses, increase in efficiency. You know, the demand reduction was 28%. You know, and the energy savings, I mean, just, it's substantial. So this is just an example. So, and I can go on and on these things. So this is just a quick little thing that I did. It was a scatter plot of losses before and after. So, you know, pretty much shows you where the losses were before and after. And this is a scatter plot of efficiency before and after. So it's there's a lot there. So, I mean, you guys have any questions? Anybody have any questions? I know I'm going pretty fast because I'm looking at the time and we're coming up on it. So, any questions?
Yeah, Tim. Oh, go ahead, Deb.
Yeah, so two quick questions. One, you showed some of the manufacturing images. Where are these? Where are these manufactured, and do the components and the overall manufacturing check the box for, you know, Buy American, things like that, different sort of, you know, domestically produced or domestic content requirements? So
we are built in Toronto, Canada.
Okay.
But we meet all the requirements for Buy America, you know, all the NAFTA stuff and everything. We meet all those requirements because we're on federal projects. I mean, that's probably one of our, I'd say 40% of our business is federal projects. I mean, we've done the U.S. Capitol, U.S. Senate buildings. I mean, like I said, Joint Base San Antonio, I'm looking at right now, Goodfellow. I mean, it just goes on and on there in Texas. So we do check all those boxes. And we don't have any issue with whatsoever. Right now, we're looking at every GSA facility in Texas. So that's a big undertaking. I mean, but we're looking at that right now. We're actually starting the audits in the next week or so. Should have been done 6 months ago, but with COVID, we couldn't get in there. But yeah, we don't have an issue with that whatsoever. We'll show you all the documentation and so forth and so on.
And one other quick question on kind of the timing. What sort of time requirement is involved in, you know, a typical retrofit installation? Is this a couple of days on site per room or per?
No, I mean, it depends on the electrical contractor. So I mean, I just had a guy install 23 of them in 2.5 days.
Gotcha. Okay.
So it really depends. I mean,
Yeah.
I always say, if you get somebody that has not done it before, then they're a little slower,
Sure.
but then they speed up and speed up and speed up and speed up. So then they knock out a whole school in a weekend, or 6 or 8 a night or something like that. So we're making it easy on them too, because what we're doing is we're building the transformers similar as possible to what's existing. So if you go down to like Gray Barn, just pick up a transformer, you don't know what size you're getting, physical size. You don't know what kind of lug configurations, you don't know what kind of impedance. And impedance is a big deal, because if you start messing with impedance on a transformer, then you're going to have to worry about arc flash studies being done again, and short circuit studies being done again. And nobody wants to do that, because that costs money, lots of money. So we're looking at all those types of things. So we try to eliminate as much as we can. Even like I said, I was mentioning the pallet. I mean, the installing contractors always say this: we love this pallet, because if you think about it, you've got a, say, 150 kVA transformer sitting on a pallet. It weighs half a ton. Okay, so how are you going to get off the pallet? You're going to have to get 6 men and a horse to get it off the pallet. And now with ours, you just pull it up, drop it in, and unbolt the pallet that goes around it. So there's no lifting or anything like that. So those things reduce the installation cost and the installation timing. So then it reduces the installation costs. So hopefully I answered your question.
Okay. Thanks, Tim.
Yep.
Tim, I have a few questions. First of all, I am very impressed with, I don't think that transformers are necessarily the first thing that comes to mind when people think of an ECM. And my previous life, I was a lead consultant, and in those years, specific ECM around transformers didn't necessarily come up, and I'm kind of surprised that it seems like it's a really underutilized ECM.
Oh, there's no doubt about it. And I run across this all the time. I mean, it's just one of those things, like I mentioned to you earlier, was a lot of the people, they're always looking at low-hanging fruit stuff. And of course, HVAC and so forth, because that's comfort. And they're always trying to look at those types of things. And again, you see the slides that I showed. I mean, they're just stuck in an electrical closet somewhere. Nobody even thinks about them. I mean, they just, they walk in the mechanical room. Like I had one particular one here recently, was the project development engineer said, "Hey, I was at this facility and I found 2 transformers." And I said, "How big is the facility?" And he says, "Like 300,000 square feet." And I go, "Well, there's more transformers than that." And he goes, "No, that's all I found was 2. And I go, "Well," then he sent me the electrical one line, and it was like 40 of them.
Right.
And I said, I go, "Well, you found 2 in mechanical rooms, because those was the only rooms that you were in. Did you walk in the electrical rooms?" And he goes, "No, I never thought about that." And I go, "Well, that's the reason why you only found 2, but one line showed 40. And when we went out there, we confirmed it." So, and like I said, majority of the people, gals and guys, and they're in this industry are mechanical engineers, and they just don't think about it. And I'm trying to bring that to the forefront to everybody. I mean, I want this ECM, when they go out to a project, they're looking at lighting, water, building envelope, chillers, boilers, transformers. I want transformers to be in that conversation. And a lot of I'd say a good bit of the ESCOs know that, and they'll do it, but then they get off the beaten path, and they start running down a path, and they get their 5 little ECMs that they really like really well, and they just do those. I mean, and I have to bring them back in the fold. Yeah, I keep on forgetting about those transformers. And I go, "Well, I mean, I don't know why. I mean, you're not generating more revenue. You're trying to bundle as big of a project as you can, because a lot of these projects, you only get to the table one time. I mean, in a span of years. So if you don't bring everything to the table at that one time that you bring everything to the table, then that ECM is just going to sit there and, lose energy for, until you guys think about something else again, 10, 15 years down the road." A great example. This is a good example. I just thought about it. So I did Central Texas College, and I think it's outside of Waco or something. It's a pretty large college, but it's off the main interstate. I remember that. It was probably 12 years ago, maybe something like that. And so I got a call from the ESCO probably 3 or 4 months ago. And he goes, I wanted to let you know, he says, we're doing another phase out here. And he said, the only ECM, he says, all the HVAC, all the lighting, he says, all the controls, everything has been replaced on this project already. And he said, the only ECM that's still sitting there is your transformers. And I go, well, that's good. Spread that around. He says, yeah. He says, but you're not going to repeat business. And I go, well, I know that, but I mean, that's what we knew that up front. So, I mean, why not do it? I mean, it's usually such a small piece of the whole overall project that, it's not going to hinder the project. Our ROIs aren't the best in the world, and that's what everybody looks at. But you look at SIRs, we're great. I mean, like in California, they have to do the savings to investment ratio calculations for every ECM, if it's K through 12 or community college, to get Prop 49 money. And so ours is number one on the list every time. They have lighting that drops off the list before the transformers drop off the list, because you have to hit a certain SIR to be considered for funding for the project. And if you don't meet that SIR, you're not on the project. So our transformers are number one, never get knocked off a project. But other things that you'd think typical is, if you look at the return on investment, might be lighting. But yeah, I mean, how long is lighting really going to last? I mean, I've had projects, a very, very large project that probably took 5 to 6 years to complete. And before the project was even over with, they had already started replacing the lighting. And I asked him about it. I said, why are you guys replacing lighting? He said, well, now it's from TH to LEDs. The LEDs are better now, and now we're using LEDs. So, and he goes, I go, well, you just replaced those ones 3 years ago. And he goes, yep, but the energy savings is there. So, you've got that aspect of it. And it might be low hanging fruit, low return on investment, but ours are not good. I mean, sometimes it's 10 to 15 years. So, I mean, I just did a project down like at El Paso. I think it was 12 years, something like that. And they replaced every one of them, El Paso ISD. And we're doing the same thing at Goose Creek. And I think Goose Creek is a little higher than that, actually. But they're still doing it because they understand that this will outlive the contract term. So if you have a 15, 20 year, 25 year project, this is the only ECM that's going to outlive the contract term. I was at a presentation before COVID, and a financial guy was up there talking, and he was, I think he was with Bostonian, if I'm not mistaken. So he's talking about ECMs, a very, very smart financial guy, but with an engineering background. So they were talking about how they looked at interest rates on particular ESCO projects and performance contracting projects and so forth and so on. He was talking about, the risk involved in that particular ECM and blah, 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 and the whole 9 yards. And the one thing he said was, he goes, the one thing we look for is we look at ECMs to help the whole project that will outlive the contract term. And it was funny that half the room turned around and looked right at me. And I said, I didn't tell him to say that. I mean, I didn't tell him to say it. And he goes, and afterwards I walked up to him and I said, thanks for saying that. And he goes, well, I didn't want him thinking about you, Tim. I wasn't even thinking about you. I was just telling you the facts. That's what we look at. That's how we look at the analysis of the interest rates it's going to go on these projects, is looking at the overall project. And if there's ECMs in there that outlive the contract term, then why not do it? So just an FYI. So
I'm curious, I have one more quick question.
okay.
What kind of proportion of the building's overall energy use do transformers represent? And you mentioned lead a couple times, and you mentioned sort of how the savings is calculated. Is there a code baseline that energy models, the ASHRAE 90.1 energy models, can calculate against so that you're actually able to claim the savings in a lead energy model?
So I'll send you a document in reference to that. Typically what they do is, how that one spreadsheet, I mean, I'm lead, but it just, I haven't done it for a long, long time, but there's a spreadsheet that you can have all your ECMs and so forth, and you can add a line item to that. You can add a line item for the transformers on that spreadsheet.
And then you define the baseline.
Right, exactly.
Got
Right.
it. Interesting.
Yep.
Yeah,
Yep.
that's great.
Yep. And so, I got my train of thought. So, okay. So why Powersmiths? Okay. We've already talked about energy resiliency. This is a big deal on resiliency overall, because I mean, if you lose a transformer, you're down. So, and we're seeing a lot of that on the government side of the business, federal and the state government side of the business. We're looking at resiliency, and they're looking at it going, hey, this transformer feeds the whole building. On the medium voltage side or the low voltage side. And if this thing goes down, we're done. So, I mean, you can have all the backup generation in the world, but if the transformer's out, then the loading on that transformer's off. So they look at that. We provide the turnkey project development. We're looking at transformers to try to optimize the load application. And, we're all across the federal markets. You name it. I mean, you name it, we're there. So, transfer again, just to understand why do it, the KW and KW demand, KWH and savings and KW demand embedded for 30 years, minimal maintenance. There's no maintenance on transformers. I mean, there's nothing that you could do. There's no controls. I mean, how all these things can be adjusted and messed around with after the project is complete. So many times that I see this. I mean, the ESCOs come back and says we have to reconcile the savings from 3 years ago because they're really leaving the lights on for 16 hours a day instead of 12 hours a day. And we have to reconcile the whole project and savings calculations and justify why we're not meeting our goals. And I go, with transformers, they always say to me, the transformers I never have to worry about, because the no load losses are really the core losses, and that's where the majority of the losses are. So we know what the core losses are. So you guys know what the core losses are. You told us what the core losses are, and the new ones. So that's what it is. So no efficiency or loss aggregation over installed life. We're backed up by a 32-year warranty and performance guarantee, and most sustainable ECM you can install. I mean, name me one ECM that will last you for 30 plus years. I mean, there is none. So, and guaranteed savings for your clients. So that's pretty much it. I'm going to wrap it up. And last thing is questions, but you guys have already been asking a lot of questions. So is there anything else from anybody else? Dub or Cassidy?
Yeah, none from me. I don't see any in the Q&A chat box, but Tim, I'd like to thank you. This is a little bit different of an ECM than typically we see, but I think this presentation today and your expertise and practical knowledge with installation is exactly what we're hoping to convey through these Texas ESC chapter education webinars to help the companies themselves better understand kind of state-of-the-art technology and how it can be packaged in their overall solution. So this is sort of, this hits dead center with what we're looking for. I think the intent of the educational webinar. So appreciate your time and
not a problem,
and being with us today.
How many people did we have?
I think, Cassidy, what do we have?
We still have a few folks on the line, but we had 5 folks join.
Okay.
And then we'll have this recorded as well.
Yeah, we'll post it to the website and get it distributed to the rest of the chapter.
Yep. Okay, cool. Perfect. Well, I appreciate you guys, and you guys have a blessed rest of the day and the rest of the week.
All right. Thank you.
All right.
Thanks, Tim, and thanks everyone for attending.
Thank you. Bye.
Yeah. Bye.